co-founder of the Forze hydrogen racing team. Show us the beautiful pictures that you have, what you're doing. Take it away.
Thank you very much. Well, hello everyone, good afternoon. My name is Corné van der Grint. I'm a partnership manager at Forze Hydrogen Racing.
I am Olivier Sorgy, and I'm the Chief Fuel Cell and Powertrain of Forze Hydrogen Racing.
And if we, yes, perfect. So we'll take you along on the road on how we race on hydrogen towards a sustainable future. And we do that because we're a student team of over 50 students, and we build a hydrogen-powered Le Mans racing car. But then the question is, why do we do that? And we do that to show what hydrogen is capable of and to educate ourselves because we're the engineers of the future. But let's take a step back and have a look at how we started and what we did in the history of Forze. Well, as you see, in the beginning, we started in 2008 with a small go-kart powered by hydrogen. And over the years, the hobby of some enthusiastic students escalated a bit quickly. So the first 3 years, we raced in a class called Formula Zero. This was a class by the FIA based on zero emission, and we entered with the Forze 1, 2, and 3. And with the Forze 1, 2, and 3, we won the competition in 2008, 9, and 10. In that time, the group was a little smaller. We had no business operations as we have now, and hence we were not that creative on the marketing side. So our name Forze comes from Formula Zero. Then you can win the competition over and over again for the fourth time. But as you see in the DNA of Forze, we took a step backwards, take a look at how can we improve ourselves, how can we challenge ourselves again, and how can we go to the next level. And that's how we came to the Forze 6. The Forze 6 was our first real racing car, and it set the lap record at the Nürburgring for hydrogen-powered racing cars. And that was done by famous Le Mans winner Jan Lammers. But yet again, only setting a lap time is not enough for Forze, because as I told you before, we want to challenge ourselves to be the best possible. And to really show what hydrogen is capable of, and to really show what good of a technique we have, you need to compete. And you need to compete to other petrol cars to really show what your power is. And that's when the Forze 7 came into life. The Forze 7 was the first car to compete against normal petrol cars. But again, only competing is not enough. We want to win. And that's why we developed the Forze 7 to the Forze 8. And that's the first time we stepped on the podium. We competed in the Supercar Challenge here in the Netherlands. And the first time we stepped on the podium was in 2019 with the Forze 8, and we took a second place. But as I told you before, second place is not enough. So yet again, we took a step back, thought by ourselves, how can we develop, how can we improve, and how can we challenge ourselves to the next level? And that's how we come to our current project, which is currently at the dyno in Delft, the Forze 9. The Forze 9 is again an improvement, a whole new chassis, all designed in-house by ourselves, by our engineers, and it's capable of going at 300 kilometers an hour, 0 to 100 in 3 seconds, and has a total boost power of around 800.
So this car is going to be our fastest car yet. But first of all, what even powers our car? In our car, we will have 2 stacks. The stacks are the things that produce our electricity. But how in the first place does a stack even work? Our stack is a proton exchange membrane stack. That means that on one side, on the anode side, we'll have hydrogen coming into the stack. On the other side, we have air with oxygen also coming in. Then the hydrogen and the oxygen bind to the membrane. The hydrogen loses its electrons, which is our electricity that we use to race. And then the protons go through the membrane, combine with the used electrons again, and form water that will be expelled out of the cathode again. So the anode side is the hydrogen side, the cathode side, the oxygen side. This electricity that we produce is being put into a buffer charge, the accumulator. This accumulator can also be used as a kind of boost power. With that boost power, we can produce over 800 brake horsepower that will propel our car forward. Then, in our car, the anode will look like this. There's 2 stacks again, and on this side, is more hydrogen control systems, and on the other side as well, because they are two separate balance of plants. So two complete separate systems that provide everything to the stack that we need. Then we also have the cathode. It's much bigger, and it's placed here in the car, and exactly on the other side of the car on the right, there's a completely identical system as well. With these systems, we are able to produce the power, as we previously told, with our stacks. So, the electricity that we produce, as I told, goes to our buffer charge, the accumulator, which is this big orange block in the middle, and that divides the electricity over our front and rear motors. These motors, the fact that we use 4 motors gives us extra torque, which makes our car go faster, and we also use torque vectoring, which enables our car to go faster around corners. What we also do with our motors is they're electromotors, which means that we can also use them to recuperate energy back. This system is so efficient that when we brake into one corner, we can recuperate as much energy in that one corner as a Formula 1 car can do in an entire lap. So this system increases the efficiency of our car and makes us able to drive even further and even faster around the circuit. Then, as we push the bounds of what's even possible engineering-wise, and we want to race, we obviously walk into challenges that we have to overcome for our car to be the fastest hydrogen racing car ever.
Well, as we are pioneers on the field of hydrogen racing, we not only develop the hydrogen side of the project, but we also have to think about certification. As we're the first doing it, we need to think about safety, homologation, and a general documentation of our whole progress, just to keep other people informed, and also organizations like the FIA up to speed on what we're doing. And next to that, since that we really believe in hydrogen as a sustainable energy carrier for the long distance, we built Le Mans racing cars. But if you want to go to Le Mans, or if you want to do an endurance race, you need to refuel on track. And currently, it's really difficult to refuel on track, and that's some challenges we have as well.
Yes, and then on the more technical side, we have as a challenge also the cooling in the car. A hydrogen-powered car with a fuel cell has so-called low-grade heat. This means that the temperature of the heat that we have to remove is very low compared to the ambient temperature. So our waste heat is around 80 degrees, and the ambient temperature is 20 or 30 degrees. So it's a very small temperature difference, which makes cooling harder. That's one thing. The other thing is we're a racing car. We want to package our car as small as possible, to make it as tightly as possible, but still we want to fit 2 stacks in there, 2 complete systems to create electricity, which also poses a big challenge, because it's the first car with dual BOP 2-stack setup to ever be created. So that creates a challenge from a packaging side. And it's a racing car, so we also still want to keep the weight down, even though we want to integrate as many systems as we want. So these 3 things are the biggest challenge from a technical side.
So, and then when racing towards a sustainable future, there are some things that we really take as a mission from ourselves. Well, firstly, as an obvious thing, we're a team of 50 or 60 students per year, and we really educate ourselves on the capabilities of hydrogen, the safety of hydrogen, and the general application of hydrogen. Next to that, as we're a student team, we change every year. Every year a new group of people come in. We have an overlap of about 2 or 3 weeks, but in those 2 or 3 weeks, you really need to get up to speed on what your predecessors have done. And in that way, we're really different from a normal company, because when you guys work there, you know, for example, at this expo, where you want to go, who you need to contact to get in, and all the other details. These are here. But if we will go next year, we need to find someone else to do it, and we need to get those up to speed. So in that way, documentation is a real important thing compared to normal companies for us. And also, as we're a student team, we just do. We think about it, but we start doing it while we think about it. Where a lot of big companies just want a whole set-out plan before they start doing something, we just think, okay, we want to go here, we're really motivated to do it, and we just start doing it, and we'll figure it out along the way. And I think that's a great example for big companies just to start doing it. As long as you're motivated enough to achieve your goal, you'll figure it out along the way. And then lastly, we'd like to call ourselves the spin in the web, or the spider in the web. A lot of companies have a lot of knowledge on specific parts, but to really make a hydrogen system work, you need those specific companies to work together. And we incorporate all those different companies in our project just to make a hydrogen fuel cell power racing car. And in that way, we want to thank our sponsors for making this possible, obviously. And I hope we showed you how we race towards a sustainable future. And yet again, accelerate towards a sustainable future with us. And thank you for your attention.